Graphs and linear functions. Graphs. Key terms that you're going to need to know for this lesson. Axis or axes, depending on how many of them you see. So one of them is axis, two of them is the axes. Ordered pairs. Each point on a coordinate plane can be described by an ordered pair. X coordinate. This is the x coordinate. Y coordinate. Origin. Origin is at the center of the x and the y coordinate. Where the two axes meet is the origin. Quadrant. Quadrants. When the x and the y axis cross each other, they create four quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. Rectangular coordinate plane. This whole thing is called a rectangular coordinate plane. So a few of our topics for today. Let's learn how to graph a line. That's one of the main topics. But let's begin by identifying the key terms and knowing how to position ordered pairs and so on and so forth. So identify and label the following features on a rectangular coordinate system. So the x-axis. So we're going to call this axis the x-axis. So let's label that on here. Okay. The y-axis. This is the y-axis. Ordered pair 3, 4. So to locate ordered pair 3, 4, we need to move along the x direction 3 units. Start in the center. 1, 2, 3. So we're now here. We move along the x direction 3 units. We now move along the y direction. In other words, up and down. Up or down 4 units. So in this case, we're going to move up 4 units from here. 1, 2, 3, 4. That is our ordered pair 3, 4. So that point is described. This point is described by the ordered pair 3, 4. Ordered pair -2, 5. -2, -5. The first number, the first coordinate tells us to move left or right. -2, we start here and we move to the left. 1, 2. The second number tells us to move either up or down. We start here, and because it's -5, we're going to move down. -1, 2, 3, 4, and that's -5. So this point is the point -2 and -5. Label quadrant 1 through 4. So here's quadrant 1. Okay. Here's quadrant 2. This is quadrant 3 in this area. And in this last portion, this is quadrant 4. So these are the quadrants inside a coordinate plane. In which quadrant or on which axis is each point located? So the point 2, 3. So where is 2, 3? 2, 3. So 2, 3, the ordered pair 2, 3 is located in quadrant 1. The point 0, 6. 0, 6, which is this point right here. This point is located on the y-axis. So the y-axis. -2, 5. -2, 5. Here's that point, -2, 5. This is located in quadrant 2. So in quadrant number 2. Determine whether the given point is a solution to the equation. So every equation it might have 0 solution, many solution, or perhaps 1 solution. In this particular problem, we want to check and see if this ordered pair is a solution. And if it is, when we plug them in, what I mean by plugging them in is we plug -1 for x and 2 for y. If we plug them in, if this is a true statement, if this is a true sentence, then we say yes, it is a solution. So let's try it. So replace the letter y with the number 2. Replace the letter x with the number -1. We're going to go ahead and simplify this. On the left side, the equal sign separates the left side and the right side. So this is the left side. The left side is 2. The right side, you have -2 plus 4, because multiply this together gives you -2. So you have -2 plus 4. So these two, okay, so the left side and the right side equals each other. Therefore, it is a true statement. So you say, determine whether the given point is a solution. Yes, it is a solution. Try this one. Similar idea, we plug -3 for x and +3 for y. So -3 minus +3. Now, note what I just did. Before I replace the variable with a number, I create parentheses for each variable so that I know exactly what I'm replacing. Now, when we simplify this, -3 minus 3, that's -6. So -6 equals to 9. That is not a true statement. So we say no, -3, 3 is not a solution to our equation. So now you learn how to check and see whether or not an ordered pair is a solution, which also points out to the fact that solutions are ordered pairs. And some are not solutions, or in other words, many are not solutions, and some are solutions. Solutions are the one that makes the statement true. 2 equals to -2 plus 4. That's true. So therefore you say yes. All right, linear functions. Linear functions, basically in a nutshell, linear means lines. Linear functions means that functions or equations that we can graph and it will become a straight line. So this would be an example of a linear function, linear, line-er. So what do you need to know? Well, when you graph a line, the line will have a specific incline, which is described by the word slope. The y-intercept is where the line will cross your y-axis. So this is your y-axis. So the line for this particular case will cross your y-axis at 0, 2. 0, 2 is your y-intercept. X-intercept is where the line will cross the x-axis. So the line will cross the x-axis. Here's your x-axis. The line will cross the x-axis right here, which is going to be some fraction or a fraction. So that fraction is going to be something, negative something, comma, 0. Remember that the y and the x-axis, these are ordered pairs. Okay, so yeah, that's why you have to describe them as ordered pairs. Linear functions, again, linear function is any equation that can be graphed as a line is a linear function. Slope-intercept form. Okay, so this is one of the forms that we'll have to discuss about. Equations can be in many different forms, but slope-intercept form, you most likely have seen it before, must be the form y equals to mx plus b. M, or the number in front of the variable x, and by the way, y has to be by itself on the left, so y is on the left by itself, equals to mx. M is what we call your slope. So any number that's in front of the letter x is your slope. So in this case, our slope is 3, which again describes the incline, right? The b is the y-intercept. So if you look carefully, by looking at the number after the plus sign, that tells you where the graph is going to cross the y-axis, because that's the y-intercept. And that's why it's very nice to describe or write an equation in slope-intercept form, because it allows you to quickly find your slope and your y-intercept. Now, what is the slope? Well, the slope refers to the level of incline, right? So, by matching the slope-intercept form to this equation, which happens to be in slope-intercept form, we know what the slope is. The slope is 3. But can you find the slope by looking at the graph? And of course, the answer is yes, you can. How do you find the slope? Well, you start at any point you like. So for the sake of simplicity, I'm going to start here. And to find the slope, what you have to do is you have to try to move from the starting point to another point by going in left, right, up, or down. But usually we will go up first. So I'm gonna go ahead and go up in that direction. So what I did is I went up 3 units from here. And then to move to get to the next point, I started here. This is my starting point. I want to move until I get to the next point. So to move to the next point, I went up 3 units, and I'm going to go to the right. I'm going to go to the right 1 unit to get to the next point. And that's actually my slope. So my slope is rise 3, run 1. And slope, if we look at the slope graphically, slope is defined to be rise over run, and in our case is 3 over 1, and that's why it's 3. All right. Rate of change. The rate of change is another word that means slope. Rate of change. Okay. Rate of change. We are moving 3 units up per 1 minute. For every 3, it took you 1 minute to move every 3 steps. Rate of change. So rate of change is also rise over run. Okay, so rate of change is the same as slope. Let's learn how to graph equations and functions. It is easy to graph equations and functions, and there's a few ways to do it. But the way I'm going to show you now is we are going to use the slope-intercept form to graph an equation or function. So given this equation or function, by looking at it, we can tell that the slope is -2 and your y-intercept is 3, 0, 3. This equation is written in slope-intercept form, which makes it easy for me to figure this out. Once you have identified those two informations, go ahead and plot your y-intercept first. 0, 3, that's your y-intercept. And then we're going to use the slope to help us plot a second point in order to create a line. Always interpret the slope as a fraction, even when you don't see it as a fraction. So think of it as -2 over 1, because that's the same as -2. That helps us a lot when we are using it to graph a line. Start here, move down -2 units. This is rise, but because it's a negative number, we rise down. So go down 2 units, and then the bottom number is run, so we go over 1 unit. That brings us to a second point. And then we connect these 2 dots with a straight line. And that's how we can easily graph a line. Now, what is a line? Well, a line is a good way to describe all the solutions to this equation, because any point that falls on this line is a solution, and any point that isn't on the line is not a solution. As you can see, equations are the ones that has y and x. You can also graph a function. A function is very similar to an equation, but instead of having the letter y, we give it a name. So y is now referred to as f of x, which is the name of y. Okay, y is kind of like generic. F of x is a specific name for the function. But same thing, because this function is in slope-intercept form, identify the slope, which is the number in front of x. So for this particular problem, the slope is 1, and the y-intercept is 0, -3, because that's -3. Again, if your slope is not a fraction, then write it as a fraction, which means that you turn it into a fraction with a 1 in the denominator. And we start by plotting the y-intercept. So we go to the y-intercept and we plot it, which is 0, -3. That's right there. The slope is 1/1, rise, and then go over. So from here, we're going to rise 1 unit, and then we're going to go over 1 unit. That brings us to a second point. Connect the 2 points with a straight line, and you have successfully graphed your first function, which is the same as an equation. Okay. Part C. My slope, -1/2. My y-intercept, 2. Starting from, so I need to plot my y-intercept first, 0, 2, which is right here. And then rise, run, go down 1 unit, and then go over 2 unit. And this is my other line. That's a bad looking line. C. That's the third line, line C. Guess what? You just learned how to graph a line using slope-intercept form. Let's move on to complete other tasks. Now, remember that lines, you need 2 points to graph a line. So these 2 points form some type of line, and what we want to know is find the slope of those, find the slope for that particular line. Is there a way to do it without looking at the graph? And the answer is yes. So given 2 points, we can find the slope by doing rise over run. So slope equals to rise over run. Another way to find the rise is to subtract the y coordinates. And another way to find the run is to subtract the x coordinate. So we're going to apply this formula to find the slope of these points. Part A, your y1 is going to be 4. Your y2 is going to be 8. So 4, take away 8. Your x1 is 3 and your x2 is 5. So 3, take away 5. And that should bring us to -4 over -2. And that brings us to a slope of 2, which tells us that our line is going to be increasing. Part B. y1 minus y2 over x1 minus x2. y1 is 4, y2 is 7. 4, take away 7. x1 is -2, x2 is -4. So -2, take away -4. This brings us to -3. This brings us to +2, and that's our slope, -3/2. Which tells us that our line is actually decreasing. Find the slope and the y-intercept. So the cool thing is, if your equation is written in slope, the cool thing is you can find the slope and the y-intercept for any linear equation. Some are easier than the other. Some requires some work, others do not. For example, the first one, part A, the equation is already written in y equals to mx plus b, so we can quickly find the slope and the y-intercept. Part B, this function is also written in slope-intercept form. It's hard to see it, but it's missing really a number here because that number is really 0. There's nothing over here, so we can always add a 0, which assists us in finding the slope and the y-intercept. The last part, which is part C, the equation is not written in slope-intercept form, and therefore to make it easy for us to find the two items, we need to solve for y so that this equation can be in slope-intercept form. To solve for y means to isolate y, so we need to begin by moving 4x to the right. To do that, we subtract 4x to both sides. So when I subtract 4x to both sides, here's what I'm going to end up with. Divide both sides by 5. Divide both sides by -5. We end up with 4 over 5x minus 4. There you go. So that's the form we want. Slope is 4 over 5. Y-intercept 0, -4. Alright, for number 4, look at this graph and find the rate of change. Remember that the rate of change is, think of it as rise over run or the slope. So to find the rate of change, I will need to find the slope for this particular graph, which talks about the population of Bolton and also the year that has passed. So I'm going to start here. Rate of change is rise over run, right? So we're going to start here and we're going to rise down. So I'm going to make a note here. I'm going to rise, because I rise down, it seems like I rise down -300. And I'm going to run. So I'm going to run from here to here, which is 1 block, 2 block, 3, 1 block, 2 block, 3 block, 4 blocks. 4 blocks, and every block is 2 years, so therefore we run a total of 8 years. So what's the rise? What is the rate of change? The rate of change is going to be -300 over 8. -300 people over 8 years. What does that mean? That means that the population is declining 300 people for every 8 years that passes, and we can make this a bit smaller so that we can get a feel for what it is. So this comes out to be, when we divide top and bottom by 4, we get -75 over 2. So the population is losing 75 people for every 2 years. We can also write this as 75 people per 2 year to describe the rate of change, which makes sense, right? Every 2 years that goes by, the population goes down -75 people. A company's revenue is $350,000. 2 years earlier, it was $320,000. Find the rate of change. So as you can see, if you need help, read the problem again. A company's revenue is $350,000. 2 years earlier, it was $320,000. Find the rate of change at which the revenue is increasing or decreasing. So in this case, the revenue is actually increasing because it was 320, now it's 350. So it went up how many? So it rise 30,000 at the rate of 2 years. So you have 30,000 over 2 years, which simplify to 15,000 per year. Okay, and that is your rate. The company is progressing at $15,000 per year. It's making 15,000 more per year. The cost in dollars of a rental of an aerator is described by the function C of t equals to 3t plus 25. T is in hours. What do the numbers 3 and 25 signify? Okay, so the cost in dollars of a rental of an aerator is C equals to 3t plus 25, where t is in hours. what do the numbers 3 and 25 signify? 3 is the slope. The slope is the rate of change. The rate of change refers to the cost per hour, okay? So 3, so for part A, the cost per hour is $3. 25 is your y-intercept, and that's the initial charge. So the initial charge is $25. In other words, if you rent this machine and don't use it, you still have to pay $25. How much will it cost to rent the aerator for 6 hours? To find the cost for 6 hours, you plug 6 in there to the time, and that should give you the cost for 6 hours. 6 times 3 is 18. 18 plus 25. 8 plus 5 is going to be 13 with the remainder of 1. 2 plus 1 is 3 with the remainder of 1 is 4. And the cost will be $43. See you in the next lesson.